All right, today we're putting on our data detective hats. We are opening up the case file on one of the most powerful tools in all of statistics, hypothesis testing. It's the framework that helps us stop guessing and start making real evidence-based decisions. So, picture this. A team spends months, maybe even a year, redesigning their website. It feels faster, it looks amazing, and they're just convinced it's going to get more people to sign up. But here's the thing. Feelings aren't facts. How do they actually prove that the new design is any better? Well, this is exactly the kind of mystery that data detectives are brought in to solve. And that is exactly where this whole method comes in. See, we live in a world that's just full of uncertainty, and to navigate it, we need a structured way to make smart choices. Hypothesis testing? Well, that's our process. It's the official data detectives toolkit that helps us sort fact from fiction. Every great investigation, every mystery novel, it all starts by laying out the competing stories, right? The different versions of what might be true. In the world of statistics, we just call these hypotheses. So, at its core, what is a hypothesis? It's really just the central idea that we want to put to the test. As the source material puts it, it's the conceptual nucleus of our whole investigation. It basically defines exactly what we're looking for. Okay, so this is where we frame those two competing stories. First, you've got the null hypothesis. We call it H0. This is our default position, the status quo. You should think of it like innocent until proven guilty. It assumes nothing happened, no effect, that the new website design did absolutely nothing for user engagement. And this is so powerful because this no effect default protects us from our own biases. It forces us to prove our case. Then, on the other side, we have the alternative hypothesis. This is our theory, it's the story we think is true, that the new website actually did increase engagement. Our whole job as detectives is to see if we can find enough evidence to overturn that default innocent verdict. Now, before any detective starts looking at evidence, they need to know the rules of the court, right? How much proof is going to be enough to make a call? We have to do the exact same thing, so we don't end up biasing our own investigation. And that brings us to a really crucial idea, the significance level, also known as alpha. This is our pre-agreed standard of proof. It is the line in the sand that we draw before we even peek at the data. It defines how strong our evidence has to be for us to say, okay, we're rejecting that no-effect story. A super common value for alpha is 0.05, or 5%. So what does that actually mean? It means we're willing to accept a 5% chance of being wrong in a very specific way, a 5% chance of concluding there is an effect, when in reality, there isn't one. It's the amount of risk we're willing to take of raising a false alarm. Now, a real detective doesn't just have one tool, right? They've got stuff for fingerprints, for DNA. Well, a data detective has a whole toolkit of different statistical tests. You don't need to memorize all of these right now, but the big idea is that we pick the right tool for the job, like a t-test if we're comparing averages, or a chi-squared test for categories, all based on the kind of evidence or data that we've collected. Okay, we've identified our suspects, the two hypotheses. We've set the rules of evidence with our alpha level. Now for the climax of the investigation. It is time to actually weigh the data. And this is where the famous, and sometimes infamous, p-value comes into play. The p-value answers one simple question. If the no-effect story were actually true, how surprising is the evidence we just collected? That's it. It's a measure of statistical surprise. So here's the bottom line. The one thing you really need to remember. A small p-value means our data is really surprising. It's very unlikely we'd see this data if there was truly no effect. And that surprise? That's exactly what we're looking for as detectives. It's strong evidence against that innocent until proven guilty story. Which, of course, leads us to the final critical question. We have our evidence. That's the p-value. We have our standard of proof. That's our alpha level. Is our evidence strong enough to make a conviction? And here's the verdict. It's a really simple comparison. If our p-value is smaller than or equal to our alpha level, that 0.05 we set earlier, we say the result is statistically significant. The evidence is strong enough, we get to reject the null hypothesis. But if our p-value is bigger than alpha, the evidence just isn't strong enough. And notice the very careful wording here. We fail to reject the null. We never say we proved it's true, just that we didn't have enough evidence to prove it was false. But just like in a real courtroom, no verdict is ever made with 100% certainty. We're dealing with probabilities here, which means there's always a chance, however small, that we made the wrong call.
This little table shows the 4 ways things can play out. A type 1 error, that's a false positive. It's when we reject the null hypothesis when it was actually true. In our detective analogy, this is convicting an innocent person. Ouch. A type 2 error is a false negative. That's when we fail to reject the null, even though it was false. This is letting a guilty person walk free. That significance level, alpha, that we said earlier, it directly controls our risk of making a type 1 error.
Okay, so let's zoom out for a second and see how all of these pieces snap together into one single, coherent process that takes us all the way from raw data to a confident decision.
And here it is, the complete workflow, the whole shebang. Step 1, state your competing stories, the null and the alternative. Step 2, set your standard of proof. That's alpha. Step 3, you go out, you collect your evidence, and run the right statistical test. Step 4, calculate that p-value to see how surprising your evidence is. And finally, step 5, you compare your p-value to your alpha, and you make your final data-driven decision.
But why do we go through all this trouble? Well, here's the crucial point. The whole goal here is something called inference. We almost never have data on everyone or everything, so the goal is to use a small, manageable sample of data to draw a reliable conclusion about the entire population. It's pretty amazing when you think about it.
And our source material just puts it so perfectly here. This whole process operationalizes evidence-based decision-making. This isn't just some academic exercise. This is the engine that turns raw, messy, real-world data into smart, actionable conclusions that we can actually use to make better choices.
So we'll leave you with this one final thought. You now have the fundamental framework of a data detective. So think about it, at your job, in your personal life, your health, your community. What's a long-held belief or some new shiny idea that you could actually put to the test?